Hey, how are you guys doing? It's good to see you again. It's Professor Rhines out in the elements. I think this is part 9. 3-4 days ago I was in a t-shirt and wearing sunglasses and it was hot. And today it's back in the 40s. Welcome to the Midwest. This is on one of my favorite bends in a river. It's the Sugar River. And I don't know, it's easily in my top 100. You're like, 100? Yeah, I know a lot of rivers and I love a lot of rivers, so this is in the top. It's a bend that comes in, slams against this bluff, and then heads south. It's windy today, so it's hard for me to do what I need to do, so I'm going to head up to a shelter here in just a second, and we'll catch up there. So we'll see you in a few seconds. Alright, hey, this is the shelter I'm going to hang out at. You might be able to see on this chimney behind me that it was built in 1939. By the CCC, that's the Civilian Conservation Corps, and it was government work set up by it was by the government for men coming out of the Depression when they didn't have jobs, and they built things like this in our parks, along with retaining walls and establishing wetlands in places. So it's pretty cool that this is still here after this many years. Those guys went to work for that before a lot of them went off to World War II that was happening in the early to mid 1940s. So we're going to go in here where it's a little more protected so I can set up today's demonstrations after we do a little bit of reading. So you can join me in there. Alright, we're inside. I just got a fire going here. Brought some wood that I'd split up at home so I could have some dry wood to get it going. All kinds of paraphernalia today to work on our different demonstrations. One of the first things I'm going to do is get that glass bowl out of there. Figured, shoot, it's cool today. I'm going to get some hot chocolate going next to the fire since I need to get a fire going anyways. Look at that. This is just an old beat up pot, but I took steel wool to it, nice and shiny. I'm about ready to get it all sooty and black again. That's all right. It means it's well used and loved. And I've had this thing all over Timbuktu before. So get that down in there, fill it with a little bit of water. Got my mug, got my hot chocolate to stir that in after that heats up for me. So put that right next to the fire there and it'll slowly heat up. Okay, I'm gonna get the book out, we'll read a little bit, and then I'll set some of this up for our demonstration today. Okay, hey, after yesterday's storms that I had to go through, my book dried out, so that's a good thing. I'm going to read just 2 little sections today. It's mostly demonstrations, so I think you guys will enjoy that. This first section is called Condensation. You guys remember some of that from back when we did the slug drawing, the solids, liquids, gases. I'll actually come back to some of that more on Monday. I'm going to do 2 days next week. On Monday and Tuesdays we finish up this book, so I'll talk some more about slug then. The air around us always contains some water vapor, and today, after the way it came down this morning, we have a lot of water vapor in the air, although this wind is moving it around. Water molecules move rapidly through the air and hit everything in their paths. The molecules bounce off most warm surfaces, but stick to surfaces that are cold. In these photographs I'm going to show you in a second, molecules of water vapor stick to the coldest part of the glass. Gradually, droplets form on the glass as the molecules accumulate. Water vapor changes from a gas to a liquid, and when it does that, it's called condensation, so it condenses. Condense means to make small or pack together. You can actually go to the store and buy condensed milk, condensed orange juice that has water taken out of it, and then of course you can add water to it and stir it back in to make make the orange juice. But when you buy it when it's condensed, you wouldn't really want to drink it then. It's very thick and very syrupy. So the pictures of the condensation look like that. We're going to set that up today. Okay, the other part of that, well, let's set that up right now and I'll come right back. Okay, out of this water bottle that I brought. I put some ice water. Nice and cold. Brought some ice water here, and so sometimes when we see condensation forming on glasses, we think it's leaking. It's not leaking. Especially this. This is plastic container all the way around, or you have glass containers all the way around. It's sealed in there, but if it's wet around the outside, it's going to be condensation. So I'm going to set this just right here. I think you guys can see that from there. It's about 2 feet from the fire. I don't know if you can tell that from there or not, but it's quite a ways over the fire. So I'll leave that there, and we'll see with that cold. It's not as warm as I'd like it around us right now, but there is quite a bit of humidity from the rain this morning. So we'll see if it condenses, where when particles are floating around and it hits that cold surface. Remember how when it's cold, particles pack together? So if those particles pack together, it's bringing the water molecules with it, and it condenses or packs together. And we'll see if it makes those droplets on there. Okay, the next part says evaporation versus condensation. It's like a duel, fighting it out. In the photographs above, why do the water droplets outside this glass disappear while the droplets inside remain? Outside the glass, the water evaporates and spreads throughout the room as vapor. In time, the drops disappear. Inside the glass, water also evaporates. But the vapor is trapped. The air inside the glass becomes humid, which means that the air is full of water vapor, and that vapor condenses back onto the water drops as quickly as water molecules can evaporate. Therefore, the drops remain. It says remove the glass and the water expands throughout the room. It spreads out. We talked about that in the fall a lot, about how particles spread out when they have that space. Evaporation continues, but condensation slows down and stops because there's much more space for it to spread out into. In time, the uncovered drops will disappear. I'll show you that. You can see it right here, how inside of the cup, the droplets are on the table. Eventually all the droplets start evaporating around the outside of the glass, but inside that glass there's still droplets. But when they remove the glass, now these will start evaporating as well and spreading out into the rest of the room. It's hard for me to set that up necessarily right now, but we're going to move to the next part. And for that, I'm going to use a plate, and I'm going to use some water. I'm going to pour some water onto this plate. And then I have a can. And I'm going to put that can on top of here with water. Put this bowl on top. But before I put the bowl on top, I'm going to use some salt. I'm going to put salt on top of this can right here and let it all sit on top of here. When I put this bowl on top, salt draws in moisture. And it's going to draw in moisture on here. We'll see it start condensing or glomming onto those salt particles to the point where it'll actually be like droplets, or it'll be wet. If we let it go for hours and hours, it would eventually be a little puddle on top of this metal, and the salt would dissolve into those little puddles of water. But it'll be drawing it up off from this plate that I'll have here. So we'll set that up right now. I'll show it to you. I'll read that a little bit. By then we'll be ready for some hot chocolate. Okay, if you look here, I've got water. See that water with the little ripples of waves? And sealed inside of this glass is that little metal can with some white salt on top. So we'll see if that salt draws in moisture and it starts condensing around it. That'll go with what I'm reading here in a second. If we look over here at this, can you see where I make a line on there? Yep, a little bit of smoke on it. But if I go like this, maybe you can see. Actually, I could probably use a paper towel here. You can see the paper towel is dry. But if I put that paper towel around this, it starts picking up. See that where it's wet right there? It starts picking up the moisture that's condensing on this. So there's warm air around us here, has moisture in it, especially after the rain today. And when it hits this cold glass, it gloms together and starts condensing on the sides of this glass. and I can wipe it up, and you can see these wet spots on the paper towel. So you're thinking to yourself, what's with the plate and the salt and all that? Well, it comes from this section called How Clouds Form. Last little bit that I'll read to you. It says, clouds are made of tiny water droplets too small to be seen without a microscope. If a cloud droplet is to form, water vapor must first condense, it means pack around, on a particle of dust. Carried by wind, these dust particles are often bits of pollen, soot, soil, or salt. This experiment shows how cloud droplets form. Salt is placed on that jar lid or on the can above a dish of water. A glass cover traps the water inside, the water vapor inside. In minutes, the water vapor condenses on the salt and coats each grain with water. Hours later, that salt will dissolve into the water droplets, like I mentioned. Clouds form when water evaporates from the Earth's surface and rises into colder air. There, the vapor condenses on cold airborne particles. More and more particles or molecules cling to the particles until droplets form. It takes about 1 million cloud droplets to make one raindrop. Rain does not taste salty or appear gritty because the particles that allow clouds to form are usually too small to be noticed in raindrops. But here's just a little side thing. Next time you stick out your tongue and you catch a snowflake or a raindrop on your tongue, just know that somewhere in the center of that raindrop is a little salt, dust, or dirt, pollution particle that the water vapor is condensed around, almost like a jawbreaker where it has all the layers. It has these particles that have gone around it. All right, we'll take a look here in just a second at our experiment demonstration. Okay, let's check it out. It's not like all the salt will have dissolved, but let's see if it's at least starting to get wet. We'll know it's wet because it'll start sticking. Normally it's dry. You can maybe see on my finger, starts sticking. So what's happening is this salt draws in moisture. Salt draws in moisture. It'll dry things out. And so the water that was down here, trapped inside of this bowl, was in this air. Salt drew it in, and it'll start pulling the moisture in here, and that's the same thing that happens up in the air with our clouds. It draws it in, the droplets collect on that salt or dust, and then falls as rain like it did earlier today. All right, so we got to see a little bit water that was spilled all over the cement is evaporating. That's going from a liquid into a gas. We got to see condensation as it went from a gas onto the coal and became a liquid. We can see how that was also happening around dust and salt particles. The salt on top here, if I go like that, some of the salt goes away, but you can see some of the salt is stuck here. The only reason it's stuck there is because moisture. This was a dry lid, dry salt, but it's sticking on there because of the moisture it was building up. Speaking of moisture, it's time to remember our tea kettle yesterday and the steam coming out of that, making it whistle? Yeah. Some hot chocolate. Stir that into my mug. I'll sign off here and sit and enjoy a cup of hot chocolate by the fire here before I head back for dinner actually later tonight. So this is Mr. Rhines, Mike, Professor Rhines. And like we like to say, peace out. We love you guys, and we'll see you along the way.